Everyone, and welcome back to another one of Tutor Taylor's videos. And in this video, we're continuing our deep dive into Euclidean geometry, and we're in the second installation of our triangles video, and today we're talking about the classification of triangles. All right, and we can classify triangles based on their sides. All right, or we can classify them based on their angles. In today's video, we're looking at their sides. Okay, and so we can have three different scenarios, and we can have three different kinds of triangles depending on their size. And the first one we're going to look at is when all sides are different lengths, which means no side is equal to another side, right? So there is no equal sides in this type of triangle. So if I drew a triangle, something like this, all right, and I called this triangle A, B, C, and I said this was a 6 centimeter side, this was a 3 centimeter side, and this was a 4 centimeter side, we can tell that neither of these sides are equal to each other, all right? Which also means that neither of the interior angles are equal to each other, and this type of triangle is called a scalene triangle. All right, so we would call this first scenario a scalene triangle, which is when all sides are different lengths and basically no side is equal to any other side. All right, that's our first classification. Our next classification is when we have two of the three sides equal to each other. So we can say two of three sides are equal. All right, so if I draw a triangle, let's draw a triangle and call it PQR. And I'm going to say that this side is 5 centimeters, this side is 5 centimeters, and this side is 3.5 centimeters. All right, now what I can do is indicate on my triangle with one straight line like this that these two sides are equal to each other. So if you remember naming convention, this would be side R and this would be side Q. So in this triangle, R is equal to Q. All right? And thus, we also know that the angles opposite the sides are also equal to each other. So angle Q is also equal to angle R. All right, and this triangle is called an isosceles triangle. Alrighty, so let's remember an isosceles triangle has two of the three sides equal to each other, as well as the corresponding angles equal to each other. So that's our second classification. And then naturally, our third classification is all three sides are equal. All right? And if all three sides are equal, the triangle, let's just say, obviously my drawings are not to scale, they're just for indication. I'm going to call this triangle XYZ. And what I'm going to say is that this is 3 centimeters, this is 3 centimeters, and this is 3 centimeters. And once again, I'm going to indicate with the straight line the sides that are equal. And in this case, all sides are equal. So if we think back to isosceles, the two sides were equal and the corresponding angles were equal. It's the same case in this triangle. If the three sides are equal, all three angles are equal to each other. And this is an interesting case, all right? Because if we know from our first video that the sum of the angles in the triangle must equal 180, so therefore angle X plus angle Y plus angle Z must equal 180, but all these angles are equal to each other, we can then say that X is equal to Y is equal to Z. So basically, we could call these angles X, and so this would be X plus X plus X is equal to 180, which we know then 3X is equal to 180, and to isolate X, we would need to divide both sides by 3, and thus we get X is 60 degrees. And that is an important fact, is that in a triangle where all three sides are equal to each other, all three of the angles are 60 degrees. So this type of triangle is called an equilateral triangle. So the properties of an equilateral triangle are three sides equal and interior angles are 60 degrees. And that's an important property and fact to know when you're dealing with an equilateral triangle. So there we have it. There are our three classifications according to sides. We have a scalene triangle where all the lengths of the sides are different. We then have an isosceles triangle where two of the three sides are equal in length and the corresponding angles are therefore equal as well. And lastly, we have our equilateral triangle where all three sides are equal and each interior angle is equal to 60 degrees. And that's where we'll wrap it up for this video. And I'll see you in the next one.